Hello everyone. The problem is that the initial value problem is that x times dy plus 2y minus x to the power 4 times dx equals 0, and the initial data y of 2 is 4. Okay, in its present form it is not easy to see that the equation is linear or not, so let me multiply both sides of the equation by 1 over dx, and it is going to be x times dy over dx plus 2y minus x to the power 4 equals 0, and multiplying both sides with 1 over x, it is going to be dy over dx plus 2 over x times y equals x to the power 3. Now in this form we see that p of x equals 2 over x and q of x equals x cubed. So in this form we see that the equation is a first order linear differential equation. So now let me solve this equation by using method of integral factor. So let me calculate the integral factor first. Mu of x equals exponential integral p of x dx, that is exponential 2 times 1 over x dx, that is going to be exponential 2 times ln of x plus c, where c is constant of integration. And now the equation can be rewritten as, or the integration factor can be reduced to mu of x equals exponential ln x squared times exponential c, and it can be written as c1 times exponential ln x squared, that is c1 times x squared. Here c1 equals exponential c. Many of students sometimes ask about why I do not use the integral factor, a constant of integration in this integral. So in fact, that's why I would like to show that there is no problem when we do not use this in the integration factors integral. It doesn't matter to use or not to use the constant of integration, since it is going to be cancelled. Okay, now let me multiply both sides of the linear differential equation, this one, by integral factor mu. It is going to be c1 times x squared times dy over dx plus c1 times x squared times 2 over x times y, and x squared times c1 times x squared times x cubed. So the left hand side of the equation can be rearranged as c1 times x squared dy over dx plus 2xy equals c1 x to the power 5. And here you see that c1s can be cancelled from the both sides, and That's why I do not use the constant of integration in the integral factor. And the left hand side of the equation is written as x squared dy over dx plus 2xy equals x to the power 5. Now let me check. The derivative of x squared is 2x here, and derivative of y is here. So the left hand side of the equation can be written as d over dx x squared times y equals x to the power 5. Then integrating both sides, x squared times y equals integral x to the power 5 dx, and it is going to be equal to x to the power 6 over 6 plus c2, where c2 is constant of integration, O integration. And now, in fact, I can easily write the solution of the differential equation, first order differential equation, is equal to x to the power 4 over 6 plus c2 times x to the power minus 2. This is the solution of the differential equation, first order linear differential equation, but my problem is an initial value problem, and I have to find a particular solution satisfying the condition y of 2 equals 4, that is when x is 2, y has to be 4. So when I substitute these two points in the solution, let me substitute these 2 points in the solution. Y of 2 equals 2 to the power 4 over 6 plus c2 times 2 to the power minus 2. And I know that y of 2 equals 4. 4 equals 2 to the power 4 equals 16 over 6 plus c2 over 4. And when I solve this for c2, c sub 2, I find c sub 2 is 16 over 3. So the solution of the initial value problem is going to be y of x equals x to the power 4 over 6 plus 16 over 3 times x to the power minus 2. This is the solution of the initial value problem.